A brand new telescope is about to transform our understanding of the universe. It's almost ready for the launch pad, months earlier than planned for. NASA's Nancy Grace Roman Space Telescope, a first of its kind observatory on a mission to map the universe one panoramic frame at a time. To help us understand all of this is Dr. Begonia Vila, a systems engineer at NASA's Goddard Space Flight Center. Dr. Vila, thank you for joining us this morning.
Good morning, Jane. Thank you for having me.
All right, Dr. Vila, let's talk about this Roman for viewers who, for the first time, are hearing about this telescope. What is it, and what big questions are we hoping we're going to answer?
Yes, this is a telescope that can take images of the sky more than 100 times wider than we can do with other observatories like Hubble and Webb. So then it's able to take those images and take the next sample of images very fast, move around. So it's going to give us the big picture of the universe that we don't have up to now. And some of the things we want to learn is what is something that we call dark energy and dark matter. We know that makes up 95% of the universe. 5% is the matter and the energy we know. We can see the effect of those dark energy and dark matter. We don't know what it is. And this telescope with that panoramic view is going to give us clue on what that might be. And they are going to determine ultimately the fate of our universe. And the other thing that's going to give us is finding more of those exoplanets, planets around other stars, in our search for finding a world similar to our own.
Wow. I mean, it sounds amazing. And this can be done with the telescope that is the size of a semi truck. Okay, everybody? So it's like a camera the size of a refrigerator. Walk us through some of the technology that it's carrying.
Yes, you mentioned already one of it. We have 18 cameras that can take those amazing views of the universe, so developing those are state-of-the-art cameras. And also, we are going to download a huge amount of data, 1.4 terabytes per day. So there is a lot of technology behind it to be able to process all that data that is available to all the scientists around the world. So how to download it, how to access it, without, crashing anything and everybody being available. And then the other instrument that is looking for those planets around other stars is taking some new technologies to be able to eliminate the light of the star and be able to find the planets around it. So lots of technologies behind it to make it work.
Yeah, and with this data available to folks all over the world and scientists, how does a team prepare for that data, and what do they do with it?
This telescope, the development where we are getting here is thanks to an amazing team. And also afterwards, this data, when it comes down, all the scientists will be able to access it real time once it's there from a cloud, and they'll be able to study and analyze their own area of expertise. Definitely looking for that dark matter, dark energy to understand it, looking for those new planets, finding billions of new galaxies and stars and trying to learn more about how they form, they evolve to ultimately get to a galaxy like ours and a planet like Earth where we are.
You've spent years on this. What does it feel like now to know that it is right? It is happening almost right now.
Exactly. I think it's the end of a ton of work, long hours for all of us on the team. We are a few weeks away from shipping it to the launch site on Kennedy Space Flight Center. From there, we'll be launching on a Falcon Heavy, so we're all super excited. It's so close. And then, obviously, once we are on orbit, 2 or 3 months afterwards, we'll be releasing those first few images. So I think we are all excited and looking forward to the next few months.
Anything from this moment then, and really the work behind this that has stood out to you personally?
Yes, definitely. Every time you launch something into space, you have to do all these tests to make sure it's going to survive the worst part, which is the launch, right? That rocket is going to shake whatever you are sending and it's going to vibrate a lot. But we also need to duplicate the conditions that the observatory will see on orbit, right? The vacuum and the cold temperatures. And I was lucky to be leading that particular test and then be part of the team for operations. Right now, we want to make sure that everything works as we plan it, and we do get all those images and spectra down to the ground for everybody to use.
All right. Anything else we should know or go to for more information?
Yes, you can go to nasa.gov/Roman or on social media at nasa.Roman and watch for that exciting launch and then our operations and those first images that will be coming down.
All right, congratulations. I'm looking forward to it. I am following you as well. Dr. Begonia Vila, appreciate your time this morning.
Thank you.